Today we're going to check out some indoor TV antennas. I have some rabbit ear style antennas here from 4 different brands: Fosmon, On, Stellar Labs, and Zenith. We're going to have a look at each of these and then test them out to see which one offers the best indoor signal strength. All of these antennas are combo units with a UHF loop of some kind, as well as extendable dipole elements for VHF reception. A couple of these models specify they're suitable for FM radio reception as well, but all of the antennas come with a length of that thin coaxial cable that is attached directly to the antenna. The Fosmon antenna cost me about $18, and it has a triangular UHF loop built into the base. It can be placed on a flat surface or hung on the wall, and the VHF dipoles extend to 14 inches. The On antenna cost me only $5 on clearance, and it has a traditional circular UHF loop antenna. The dipoles for VHF extend to 15 inches, and it has a weighted base that gives it a sturdy feel. The Stellar Labs antenna cost me about $12, and it has a flat panel style UHF antenna. It has a lightweight stand, and the VHF dipoles extend to 15 inches. It also has the thickest coaxial cable of all the antennas. The Zenith antenna was a little more expensive at $25, and it has an odd-shaped hexagonal UHF loop. The dipoles extend to 20 inches, but I noticed that they are a little more upright and don't angle down as much as the other models. I only get 3 over-the-air channels in my area, and they're all on the VHF band. 2 of them are on the low VHF band, channels 2 and 4, which used to come in beautifully during the days of analog TV, but ever since the digital transition, these 2 channels are almost impossible to receive indoors with rabbit ears. So today we're going to use channel 9, which is on the high VHF band, as our test channel, and we'll find out which rabbit ears give us the best signal strength. And to keep this test as fair and scientific as possible, I'll test each antenna one at a time, making sure that they are positioned in the exact same location and orientation with the dipoles fully extended, and they'll be connected to the digital converter box using only their attached pieces of coax cable. The Stellar Labs antenna produced an average signal strength of 60%, but it also produced the most stable signal, with the level only wavering by a margin of plus or minus 3%. The Fosmon antenna produced the highest average signal strength of 63%, with a signal fluctuation of plus or minus 4%. The Zenith antenna produced the lowest overall average signal strength of only 57%, this despite the fact it had the longest VHF dipoles. The signal also fluctuated the most with this antenna by a margin of plus or minus 9%, and a range between 52 and 61%. The On antenna produced an average signal strength of 62% with a signal fluctuation of plus or minus 4%. For the final results, the Zenith antenna placed 4th, no surprise here. It had the lowest average signal strength by far and the wildest signal fluctuation as well. Despite having the longest VHF dipoles, the design of this antenna makes it impossible to angle those down low enough to really capture VHF signals effectively. Now, it does have the largest UHF loop out of the group, so it might fare better on strong UHF signals. In 3rd place was the Stellar Labs antenna with a decent average signal strength and the narrowest signal fluctuation margin that gave it the most stable signal of all the antennas. 2nd place went to the On antenna, which placed 2nd in average signal strength, signal fluctuation, and as well, this antenna was able to keep the signal at 60% and above the entire time. 1st place went to the Fosmon antenna by a close margin. It had the highest average signal strength, a pretty good signal fluctuation margin, and it was able to keep the signal at 60% or above the entire duration of the test. Keep in mind this test is measuring signal strength on VHF channels. You could probably expect better reception results with UHF channels, which tend to broadcast at higher power levels, And in light of the TV spectrum repacks, a larger UHF loop may be even more advantageous. Whether you're using an indoor antenna as your main antenna or as an antenna on a second TV to pick up some channels in another room, using indoor antennas do come with certain considerations. First and foremost, an indoor antenna is never going to outperform a good outdoor antenna. The power of the broadcast signals in your area, the distance you live from the broadcast towers, as well as terrain variations in your area, such as mountains, hills, or valleys, can all have an effect on your reception. Obstacles like trees and buildings can also affect how good your reception is. And the building materials your home is made of can also play a major part. For example, if you have a metal roof or metal siding on your house, that is going to drastically reduce your indoor reception. The other thing to consider with indoor reception is that you're more than likely only going to be able to pick up major TV stations in your area that broadcast at high power on the high VHF or UHF TV bands. I wouldn't expect to pick up low VHF channels or low-powered TV channels in your area with an indoor antenna. There's a couple of things you can do to maximize indoor reception that have to do with antenna placement. First, try to place your antenna as high as possible, either up on a shelf or hung on a wall if your antenna is designed to do that. Second, try to place your antenna either in or near a window that faces the direction of your local broadcast towers. Something else that might help is a signal amplifier. Check the description for links to some videos I've made covering this topic. One takeaway here is that price does not always predict performance. In this case, the most expensive antenna, the Zenith, did the worst. The antenna in the middle of the pack, the Fosmon, which was priced at about $18, did the best. And the antenna that was the cheapest, the On, which I got for $5 on clearance, came in a close second place.